Hi, Dan.
I am. I just started.
Hi,
Yeah, hi, Dan. All right, moving on.
Dan.
No. And Megan's also gone, so Megan's probably listening as well. All the asymptotes and intercepts, holes, rational functions are labeled. Sketch a graph of f and find an equation for f.
Fun stuff.
Okay,
Already did this one.
great.
All right, we can do it now.
On this one, it says it crosses, so that means the point 0, 6 is on your graph. The point 3, 0 is on your graph. That is the next intercept. The next intercept comes from the numerator. Remember, f of x equals g of x over h of x. So that means in the numerator, you have to have a factor of x minus 3. All right? And it says there's a hole in the graph, so that's removable discontinuity, removable, at x equals 4. I have to come up with an equation. Okay? So I know there's going to be a line right there. I know if I put 3 in for x, y will equal 0, hence an x-intercept. I also know if I put 4 in for x, I will get 0 over 0 out for the numerator and denominator, so it must be a factor of both, x minus 4, x minus 4. Okay. I also know that the graph does not cross the horizontal asymptote. It doesn't say that, but I'm going to assume it does not cross the horizontal asymptote. I also know there's a vertical asymptote at x equals -1. So if I put -1 in the equation, I get some number over 0. So it has to be a factor in the denominator. It says x plus 1. Okay? So this is the vertical asymptote right here. This is the hole in the graph, those two together. And this is the x-intercept. I've got those 4 taken care of. Okay? I need some more pieces to the puzzle. So I'll rewrite this, x minus 3, x minus 4, x plus 1, and x minus 4. Okay. I know the graph does something like this, goes down, crosses, hits, follows this. And I also know that the graph goes something like this because it can't cross the x-axis again. There are no more x-intercepts. So finally, that leaves me with this point and this horizontal asymptote. If I put in 0, I need to get out 6 for y. And the degree of the polynomial has to be the same. So the numerator has to be the same as the denominator. And when I divide the leading coefficients, it has to equal -2. Okay? So I know it has to be a -2 over 1, but I don't know what a is. The degrees have to be the same. A is determines your width, and I'll get that by putting in 0, 6. Remember to always find a, you always put a point in. Okay, a could be 1 or it could be a different number. Yes? Because since it has a horizontal asymptote at y equals -2, I know the degree of the numerator has to equal the degree of the denominator. Okay? So that means the leading coefficient divided by the leading coefficient has to equal -2. All right? So I'm just picking -2 over 1. Could be some other multiple. I think I'll put 0 in and see if it comes out to equaling -6. I hope so. That means a would be 1. Or it equals 6. So 6 equals -2 times a times 12 over 1 times -4. Yeah, so -24 equals -24a. So a would equal 1 in that case. Bless you.
Why would you have to find the A now?
Well, I don't think I would in this case since there's a horizontal asymptote there at 0. But normally, you have to look to see if there's a constant being multiplied by something. I think in this case it would always be 1 though. That's just a check also, just to make sure it works. Sometimes there could be something other, I guess. If this was like -6/3 or something, I don't know. But it'll always reduce down. So I guess it's more of a check than anything. I was thinking you had to find A for some reason. Okay? So the equation is just going to be f of x equals that equation. Now, it looks nice and harmless on this picture, but if you put this on the TI, it's going to be very difficult to read. So you need to know how the TI looks when you're going to read something like this. We're going to graph it out real quick, so you can see all the different things. I know I'm nervous I'm being recorded. I always get nervous on record. Okay, it's all right. Oops, not that one. View, show, hide, y equals -2, parentheses, x minus 3, x minus 4. You need a double parentheses in the denominator for grouping and one for factoring. X plus 1, x minus 4. Okay? And then that's my factor, and this is for my denominator, so I need an extra set. Graph it out. Oop, zoom 6. Okay, so there you see the horizontal asymptote. You can see the vertical asymptote coming down right there, and you can also check by putting in 4 and making sure there is no value. So I can calculate value at 4, and there's one, so there's a hole in the graph. You can't see the hole in the graph because of the pixels, but you get the idea of, there's the horizontal and there's the vertical asymptotes. Okay? Nice. Love it when a plan comes together. We can do a few problems today. We got all the notes taken care of, right? I said we can do a few problems today because we got the notes taken care of. Our little checklist. What's the x-intercept? X-intercept? Dean?
Well,
Does -3 equal 0?
no.
There are none.
I was about
Okay.
to say that. I really was.
Good, Dean. I'll give you the y-intercept.
Y-intercept, that would be -1.
Very good. Nice. Domain. X cannot equal what?
3.
And is that going to be a vertical asymptote or a hole in the graph? Yeah, vertical asymptote. Because if you put -3 and you get -3/0, so it's going to be a vertical asymptote at -3.
Of course.
I know, it's okay. Number 4, horizontal or oblique asymptote. What's the degree of the numerator? 0. The degree of the denominator? 1. So it's going to be a horizontal at y equals 0.
So wait, what's the vertical asymptote? 0? Wait, -3.
Vertical asymptote is at -3. If I put -3 in f of x, I end up with -3 divided by 0. That's an algebraic indication it's going to be a vertical asymptote. Okay. What was 5th? Oh, does it cross? So you substitute your equation for the horizontal, set it equal to f of x, and it will not cross. No. Because you cross multiply, 0 will not equal -3. Okay? Cool, chill? Okay. So far, so good? Fantastic. Oh, what's it going to do on the left side of -3? As x approaches -3 from the left, that means you put in like -3.1. Will it come out to be positive or negative? Positive. So that means on the left side of the asymptote, it's going to be positive infinity. As you approach -3 from the right, you put in like 3.1 or negative 2.9.
And that would be negative. Why is that positive?
A negative divided by a negative is going to be a positive.
I mean,
On the left side, negative 3. 1, 2, 3. It'd be like negative 3.1. So negative 3 divided by negative 0.1 will be a positive number. And then on the right side will be a negative, so it'll be negative infinity on the right side of the asymptote. Okay? Y-intercepts, what do we say, negative 1? I love it when the plan comes together. There are no x-intercepts because there is a horizontal asymptote there. Is that it? It's going to go up here on this side, and I know it's going to be down here on this side. So I just connect the rest of the part. Remember, the horizontal asymptote is like the end behavior of the graph. So I know it's going to hit and go something like this. Now this is going to go something like that. And that's pretty much everything, I think. Everything. Have all our points over here and have our picture right here. If you want to label the picture, you can. Right now, the calc kids are labeling graphs again also. They're putting in some extra points so that you don't have yet. Okay? Questions on anything? Yep. No, there's no button you can press for a horizontal asymptote, but there's just a way the graph behaves. You might have to zoom in or zoom out to see what's happening, but the horizontal asymptote is just for the end behavior of the graph. Okay? Like, I know as x approaches, here's the other way of doing it. As x approaches infinity, where is y going to? Y is going to 0. See how x is going to the far right? Y is getting closer to 0. A way of putting it right here is x is going to negative infinity, then y is also going to 0. So you're getting an exposure to the going to or close to ideas in graphing, all right? And that's kind of like the next step. The next step for us is to hit the button, and you guys want to grab this one on your own or together?
Yeah, but it's better.
Together is better? All right. Are you ready to try it? Or you just want to take off on your own and see how you do? Together? You're going to C. All right, C, what's the x-intercept? Okay. Yep, negative 3/5. That's what makes the numerator n of x equals 0. 2, the y-intercept. Carl? Yep, negative 3/7. I set x equals 0. Number 3, horizontal or oblique asymptote. Which one?
You call me Carl.
I did? Oh, sorry.
no, that's fine.
It's on audio
Here you
tape.
go.
Okay, Haley, you're up. Okay, we'll get to it. Yeah, y equals 5/3. Will it cross? Will it cross? Yep. Minus 35 equals 15x plus 9. No. The 15x's will cross off. Negative 35 doesn't equal 9, so it will not cross the horizontal asymptote. Well, you end up with something like 2x equals 6, so x equals 3. It'll tell you where it crossed at. Okay?
So, like, if you got 9.
It'll give you a point, a coordinate, or an ordinate, or abscissa. Which is it? Ordinate, I believe. Okay. Now the discontinuities. X cannot equal what? 7/3. Vertical asymptote or a hole in the graph? I think it's vertical asymptote. As x approaches 7/3 from the left, is it going to be positive or negative? Well, that'd be like, the top up here is going to be positive, right? Because it's a positive fraction. And down here is going to be negative, isn't it?
So how you do that, you fill in that number for x.
Yeah,
And see what it is.
right. You're seeing what happens on both sides of the asymptote. And if it's just short of 7/3 and you're subtracting 7, well, it's going to be a negative number. So I go to negative infinity. As you approach 7/3 from the right, like 8/3 or something, the numerator will still be positive, but here the denominator will be positive because 8 minus 7 is a positive number. Get the idea? Good. So yeah, so it's going to be positive infinity on the right side. So a little negative means the left, and a positive right here means the right. Okay? All right, you're ready for a sketch. These are so relaxing. It's perfect to do on a day like this. Kind of cloudy, cool, rainy. Very relaxing. There you go. You gotta have a backup plan. Negative 3/5 is the x-intercept. Negative 3/5. The y-intercept, negative 3/7. Probably somewhere right about there, don't you think? Horizontal asymptote at 5/3. So that'd be 1 2/3. Vertical asymptote at 7/3. 2 1/3. And I know on the left side it's going to be at negative infinity. And I know on the right side it's going to be positive infinity. Positive, negative. Now I just fill in the rest of it. So I know it's going to end up over here, and I know it doesn't cross this horizontal. And I know it crosses here and here. And that's a factor of 1, so it's not going to bounce. So there you go. It's a sketch. Any questions? It seems like there's a lot to it, but, it doesn't take that long. It's like you're going to go 50 of them tonight. Okay? What? Oh. When I want to do this at Parkland, I go a lot faster. This is like a nice, easy pace, I hope. You ready to try this one? Sure! That's the spirit.
This is more of a Sunday day problem.
No. This is like here now. Take advantage of your opportunity in front of you. Nicole, what's the x-intercept? X-intercept, none. Y-intercept?
Goes.
Yeah, it would be 2. You put x equals 0 in. 3. I forget. Oh, what's the domain? Is there any restrictions?
Equal negative 1.
X cannot equal negative 1. Is it going to be a horizontal or oblique asymptote? I think Ashley knows the answer, don't you? Ashley, is this a horizontal or oblique asymptote? I'm sorry. Is it a hole in the graph or a vertical asymptote? Wrong question.
Tricky.
Yeah. Vertical asymptote or a hole in the graph? Yep, it is vertical. If I put negative 1 in there, I get 2 over 0. So that's an indication it's going to be a vertical asymptote. Does it ever cross? Well, let's... Yeah, I know. I was already jumping ahead. Horizontal or oblique? Yeah, at 0. The degree of the numerator is 0. The degree of the denominator is 2, so that's pretty easy. Horizontal at y equals 0. And does it cross? The answer is obviously going to be no, it does not. Okay. As you approach -1 from the left, it's going to be positive or negative. What do you think, Drew? Say you put in like -1.1. Yeah, you square it's going to be positive. So I go to positive infinity. If you put in a -1 from the right, say like a -0.9, and square it, it's still going to come out positive. So it's both positive infinity. Okay. Quick sketch. No x-intercepts because there is a horizontal asymptote there. There's a vertical asymptote at -1. Bless you. As you come in, y-intercept at 2, 1, 2. And on both sides of -1, it's going to positive infinity. And systematically, you just go through and surgically do the problem, and it should come out just fine. Ooh, that almost touched. Almost. But I don't have to redraw it because it actually didn't touch. It just looks like it. Looks can be deceiving.
Zoom box.
Exactly, I could, but I don't want to. Megan and Dan are probably having popcorn watching this. Yeah. Okay. No, no extra butter, no extra salt.
That's unhealthy.
You have to cut.
Exactly. I am about done with these. How far do I have to go today?
This is the last one they got to do.
Okay, it's the last one I have to do. Good. Because I have some announcements to make.
That's not allowed.
Yeah,
Are they fun announcements?
they are.
Graphing calculator now?
No. No graphing calculator for tomorrow. X squared minus 3x minus 4 and x squared plus x minus 6.
Fun.
You're supposed to factor it first.
Yep.
Sorry.
X.
Interesting, Carl. But we're doing math right now.
All right. As everybody else has done, they factored this expression.
I got that.
Got it.
Well done.
Fantastic.
That's exactly what I put.
So,
Fortunate.
what is the x-intercept?
Well. Or -1.
Very good. 4, -1. Number 2, the y-intercept.
Well, this 3. 2/3.
Yep. 0, 2/3. What's the restrictions on the domain? X can't equal what? Yeah, -3 and x cannot equal 2.
Correct.
They're both going to be vertical asymptotes because you end up with a number over 0 when you put them back into the original f of x. Horizontal or oblique? Later on you get to some oblique problems. The degree of the numerator is 2. The degree of the numerator is 2. So that means it would be a horizontal. And the leading coefficients is at 1. Now you have to see if it crosses. It's at 1 equal to x squared minus 3x minus 4 over x squared plus x minus 6. Multiply plus x minus 6 equals x squared minus 3x minus 4. The x squareds divide off or subtract off. I have 4x equals 2. So at x equals 1/2, it does cross the horizontal asymptote. Okay. I set it equal and I cross multiplied. And then the x squareds went away, but I still had x's to worry about. So I went big with my coefficients on the left, so I went with constants on the right, solved for x and got a 1/2. So at x equals 1/2, the y coordinate will be equal to 1, which is the horizontal asymptote. Okay, so it will cross. So far, so good. Now we have to see what happens on both sides of the vertical asymptote. So as x approaches 3 from the left, wish I could see the equation. I'll do this. I'll bring it down with me. Okay? So I'm approaching -3 from the left. Oh, I'm sorry, +3. Should be -3. Okay? So as you approach -3 from the left, yeah. And we have to do -3 from the right. And then we have to do 2 from the right. So if I put -3 into the left, it'd be like -3.1. That'd be a negative. That'd be a negative. That'd be a negative. And that'd be a negative. So it's going to do positive infinity. If I put in like -2.9, negative, negative, that'd be a positive. That'd be a negative. So it'd be to negative infinity on the right side. Remember, that means the left, and this means the right. 2 from the left. So it'd be like 1.9. That'd be a negative. It'd be a positive, positive, and a negative. So I'll go to positive infinity. As you approach 2 from the right, again, that'd be negative, positive, positive, positive. So I have negative infinity. Remember that little negative sign there means from the left, and this means from the right. So, oh, that was a picture. I can just grab it and throw it away. This is a great one. This one's got like everything. It's like a great movie. It's got everything. It is. That's right. That's because they don't think you can handle that yet. If I wrote the book, there would definitely be a hole in the graph right now. 4, -1. 1, 2, 3, 4. Oh, sorry. There you go. -1. Right there. And 4. 1, 2, 3, 4. Perfect. 0 2/3 for the y-intercept. Vertical asymptote's at -3 for x. And at 2 for x. Those are getting a little big. And horizontal asymptote at y equals 1. And there is a crossing point on there at 1/2 for x. And on the left side of -3, I'm on a positive infinity. On the right side of -3, I'm going to be at negative infinity. That line bothers me. It's not very straight. There, that's a little straighter. There we go. On the left side of 2, positive infinity. And on the right side of 2, negative infinity. Now you just fill it in with the rest of it. So it's going to look something like this. And it's going to look something like this, where it crosses, 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 and goes up. And then from here, it's going to go through right here and go on out. That's the complete way of graphing that one out. Okay? It was fun. Now what? Stressed out? You just relaxed.
No, it's not relaxing.
It is.
No.
It's like making bread. I made bread last night just to relax. It's very relaxing. Oh, I make it all the time. Your assignment is to go through to Let's see, compass test, 5 through 25 odd on page 264.
So that's due Friday?
Yep, that's due Friday. And this is,
I'm going through